Good evening. My name is Elie Bursztein, and today I'm leading the Google Anti-Abuse Research Team, and today with Oren from Checkpoint. We're going to tell you about how we hunted down Gooligan and how we took it down eventually. So what is Gooligan? Gooligan was one of the largest escalations of last year. It is of interest because it was the first large-scale oath stealing malware, which take it a turning point. We believe in the evolution of malware. And we have accounted over 1 million Google accounts who were affected by this botnet. So what is OAuth, very briefly, for those who don't know? How many of you know what OAuth is? Can you raise your hand? Only half of it. OK, so just very briefly, OAuth is a specification which has been used more and more. And the idea is a lot of your account have been used by other apps for identifications. For example, Twitter, LinkedIn, Google, or Facebook are using it. And the idea is when you connect to another services, you don't want to give the password, or you want to restrict the ability of people to use the service. So for example, you want to only have an account, an app to read your Twitter timeline and not post on your behalf. So to have those passwordless authorization and delegation mechanisms, the specification is called OAuth. And OAuth tokens have been used by very large providers, and they are also used in Android when you want to request access to one of the accounts available on the phone, and obviously for Google account as well. So that's what OAuth is, and so this is a passwordless delegation mechanism which is used universally now, I would say. So briefly, what happened? In about 2 years ago, around March, there was a malware, an adware called Snappy, which was discovered by Checkpoint. And this malware is relevant because it was the first one to weaponize exploits, which were originally used by the enthusiast community to root the phone and to do advanced customizations and stuff like this, or unlocking the phone. And so there was the first one and the precursor of what's going to come. A few months after that, a company called Cheetah Mobile uncovered a large malware family called GhostPush. And GhostPush is known because they innovated in the space of Android malware by providing persistency across reboots, but also flash. So what they would do is they would patch the recovery system to enable persistence through resetting the default system's settings. And then a year after that, and that's the main event we're going to describe today, Gooligan do surface, again discovered by Checkpoint. And Gooligan innovate, as we said, because they are using now OAuth tokens to do some of fraudulent abuse. And then a few days actually, after it has been discovered and we started to collaborate with Checkpoint, we were able to take down Gooligan, and we're going to tell you about this brief period of time. Before we get started and we delve into the detail on how Gooligan works, let's provide a very rough overview of how it works, because it's a fairly complex piece of software. So just to give you a rough idea of what it looks like. First, Gooligan is known to take a known APK and repackage it with extra stuff being malicious, and then they push it through social engineering or other channels to the users. Upon execution, this piece of malware will register to a command and control who do registration systems, and then go and connect to the exploit server, and the exploit server will return back the needed exploit to root the phone. After that, it's going to connect to a fraudulent app or ads-related command and control will tell you what to perform as abuse, and finally, it will either do attempt to do Play Store, fake comment and install, or will do some sort of ad injection into the device, showing pop-ups for ads, which is not Google-related, but they've been doing a few ads networks. So that's basically in a nutshell how Gooligan works. So today we're going to cover 5 points. Oren is going to start by telling you about how the infection works and what are the mechanical details behind the infections, and we'll recount how the Checkpoint discovered the backend infrastructure behind Gooligan. Then I'll come back and I will tell you how they monetize and how they were using the malware to make money. We will talk about who were the affected devices based on our telemetry, and finally, how we were able to take it down. Oren, the all yours.
Thank you, Elie. OK, So in order for us to understand Gooligan as a botnet, we first need to understand Gooligan as a Trojan, so as the Android client of this botnet. So the Gooligan kill chain is comprised of several key steps. The first of which is decoding the payload. This is a payload that is embedded into the Gooligan APK. Once decoded, among other things, this payload is responsible for dynamically downloading a rootkit. This rootkit is used to root the device, and if successful, Gooligan is now free to install its persistency kit utils. Most interesting of which is a util that enables Gooligan to infect the local Google Play process. Okay, so starting with the payload decryption. So typically the payload would be in one of Gooligan's assets. The asset is typically named close.png. Needless to say, this is not a PNG. This is, in fact, another APK. More precisely, it's a zip containing a DEX, so an Android executable. And this DEX is XORed encrypted. So this is the file structure of said close.png. So you have the payload, and prepended to the payload you have the XOR key. So that's 10 bytes of XORed key that are used in a loop. And you have a header and a footer. The header and the footer contain the same values, 5 bytes each, but in swapped order. And before starting to decrypt the payload, it is checking that val1 equals val1 and val2 equals val2. So this is some kind of weird and primitive checksum, and then it decrypts the actual payload. So this is Python code that emulates this description. You can see that the key is within the PNG, and that's just a simple XOR algorithm. And once we've decoded this payload, we can now download the rootkit. So what is Gooligan using for a rootkit? Did they develop any of their own exploits? No, no time to do that. They just used some third-party service, KingRoot. This is a very famous routing solution in Android. Don't think there's any need to introduce it to anyone that's familiar with the Android ecosystem. And the exploits that were within this rootkit were relevant for Android between 3 and 4. Okay, say we have successfully rooted the device. Now we are free to install the persistency kit. What does the persistency kit do? A couple of things. So there are a couple of different utils within the persistency kit. They are all written into the system partition. Of course, you cannot write into the system partition in Android unless you root. We did not enumerate all the different utils, but interestingly, you can see this .ls util, which is the SU binary, and it's installed, and then its permissions are changed and frozen so that the SU binary would be encapsulated just for the Gooligan malware to use. Another interesting util is the injection module that we will talk about soon. And another interesting feature is patching the install recovery script. So this was first done by Gooligan's predecessor, GhostPush. It was considered a relatively new technique, and it enables to survive factory reset. So very, very annoying for infected users. Okay, once we have all the tools in place, we can move into the fun part, which is injecting code into the Google Play process. How does that work? So the injector model of Gooligan is using the ptrace plus DL open approach. This is a very common approach among power users in Android, and it uses it to inject a shared object, IGPLD. The names are terrible. This IGPLD is in of itself another loader, but this time it dynamically loads into the Google Play process an additional DEX. So DEX is code written in Java. Gooligan developers would prefer developing their code, most of their code in Java. So this DEX contains a broadcast receiver. Broadcast receivers are basically Android listeners that listen to different system events or events from different apps. So this receiver was listening to power events, devices connected to charger or disconnected, connectivity event, Wi-Fi, etc., and screen on, screen off events. Why does it care about these events? It doesn't. These are just random events that enable it to arbitrarily wake up. What does it do once it wakes up? It downloads yet another DEX. This DEX is the real moneymaker, and it contains the actual implementation of the fraud logic that would be appended to Google Play's code. So the injection module that they used was also not code that they developed themselves. This is open source code that you can find in different GitHub repositories and in many Chinese blogs. So you can see that you have some kind of helper method that you can provide an app. It will give you the PID, and then you use this PID to inject a shared object, just like Gooligan does. Cool. Now that we have a basic concept of the inner working of Gooligan, let's talk a little bit about how we discovered. Okay, so our first encounterment with Gooligan was with a patient zero device. That was a customer device infected with a Gooligan dropper. And we found several interesting IOCs that made us look into this specific binary. Most of them were related to dropping or to routing, and among them was this non-interesting string, oversee, adjust, read, redis. So some kind of reference to an in-memory database. Seems completely boring, but on the same time, unique enough to use that to find other Gooligan samples. So we thought we would do just that. So we've searched for this string in all kinds of places, also in Google, and we found this blog. So this is a Chinese coding blog, and this specific post is talking about how to configure a proxy. Good enough. It has a reference to our string. And lo and behold, it also has credentials to the proxy we're configuring. Since we had the IP of the first proxy that Gooligan is talking to, we were able to try these credentials, and conveniently enough, they worked. So this proxy was in fact a load balancer used to balance load for the whole Gooligan campaign, and it enumerates the different Gooligan servers. Awesome. So now that we have this information and we have reverse engineered more and more samples, we were able to get a picture of what the Gooligan botnet actually looks like. And this is the simplified version. So you can see that we have Amazon servers and we have Chinese servers. After we've started the takedown operation with Google, a lot of the Amazon servers started disappearing and the whole botnet immigrated to Chinese servers. But we will describe how the botnet worked when both geolocations existed. So let's try to look at the Gooligan kill chain again, this time from a network perspective. So we have an infected device. This device is registering to the Gooligan botnet, delivering interesting metadata about itself, build, blah, blah, blah. And then it moved to talk with the Chinese server. So it's talking with this resource ggview, which delivers a dynamic link to the exploit kit. Once exploited, it's talking to the IGQ, resource on the same server. This resource is in charge of delivering the dynamic libraries that will be injected into Google Play. And this service is also in charge of delivering the actual fraud commands. What APKs should be downloaded, what comments should be made in Google Play, stuff that Elie will explain more about. And an interesting feature is that when the botnet has started to evolve, we had a dedicated service that's only doing fraud, and IGQ was only in charge of injected libraries. So we see that they're getting more speciality with their services. That's about it. Ready to talk about money?
Thank you, Oren. So, as Oren mentioned, we looked at the fraud module. So after Checkpoint found the malware, they reached out to us, Google, and we're like, oh, we have this new thing, and we believe they are stealing our token, and you should look into it because it's about 1 million. So of course we went into escalation mode, and we were collaborating, and so we spent a lot of time trying to understand what they were doing with the tokens, because the token you have on uncharged phone are very powerful. You can use them for many, many things. It turned out that the only thing they were caring about was making money. And more specifically, they were doing two things. The first one, they were trying to do app boosting, so it's directly relevant to Google. They were trying to basically sell installs and ratings to some of their clients. And they were also doing ad injection in the sense that they had a way to trigger pop-ups into your phone. And we're going to talk about how they were being able to do both of those. So for the Play Store app boosting, this is the one we understand the best because we had the most telemetry around it. They basically do something like that. They take the old token, and the reason why they wanted to use them was to interact with the Play Store. On your Android phone, when you request an app install, you actually we don't have your credential on your phone. We have this long-term token, and we exchange it, and we basically go in the App Store. When you click on the Play Store, you click install, and then basically download the app and do this through authentications. They were providing to their client what we call a full package, which is a fake install, some reviews. So not all of them were with review, but they were having also the ability to deliver reviews and ratings. So review would be like great app or something like that. And also a search term. So what they were trying to do is search for a specific keyword, let's say battery saver, and then scroll, pretend to be a click, and then do the install and then leave a review. So that's what they were trying to do in a nutshell. And what you see on the left screen is if you were to get your phone being infected by Gooligan, you will get those icons who will pop up, and they will look like what people might expect. So for example, here, two of them were installing something which would look like a game center. They are obviously not a real game center, but they try to appear as innocuous as possible so the user is not triggered by the app. And so it was all done very, very quietly to try to not raise user awareness. So one of the things which actually took us even a long time to figure out, even after the takedown was done, was to understand why on hell would they need to exfiltrate the tokens. So one thing we didn't make sense at the beginning was you have to do the fraud from the device. So why would you go to the point of exfiltrating the token out of the phone and put it into the cloud? And that was the reason why we keep investigating until we had some sort of satisfying answer. After looking and understanding better how it worked, we figured out that it's probably because the token has a way for them to emulate the device. So in the last few years, we've made a lot of progress on the Play Store to detect very efficiently fake installs. A lot of people try to do, ASEO, application search optimizations, which is basically try to outrank your competition through various means. And so we have built a lot of defenses based on machine learning and other heuristics to actually detect those things. So as a result, they grow more and more desperate. So their plan is now to attempt to masquerade as a real user. And the easiest way for them to do that at that point is to be on a real phone with real user data on a real app. And so the plan is to try to trigger, their plan was to trigger the install from the Play Store, or appearing to coming from the real app on the Play Store, from the device, and do this. So that's why we believe they were going after the Android token. The way you do this kind of abuse is in 4 stages. The first one is you take the account database, which is on your phone, and it's protected, and you should not have access to it except if you root, and that's where ends the rootkit thing, where you basically do a cat, and they get all the token and all the things. There might be other things, like every time you add an account to your Android phone, like Facebook and so forth, they're also in the database. So they take all the databases, and then they basically perform SQL-like query on it, and what they're looking for is very specifically Android Market or Android Secure, which are the one you need for specifically doing the play abuse. So they're not looking for Facebook or any other account you have, they're just looking for those. Then when they have those tokens, they go to the Gooligan command and control server and say, hey, here's all my parameters, and please tell me what to do. So basically, it's a 2-way process. So they send a request, which actually contains a lot of information, way more than we were expecting at the beginning, like IMEI, IMSA, phone make, phone model, the token, as we mentioned, the Android version, the phone carrier, the country, the public IP, a lot of information that which has no business to be there because it's not directly used, but they do that. And then, weirdly enough, the server not only tells you which app to download from the Play Store, also which search term to use, and if you need to put a rating and what would be the rating and the comment, but also what phone information to spoof. And that was a very, very weird point for a while, because you already have the phone. So the phone knows who it is, so it should just be who it is. And actually, it was not the case, so we were very puzzled by that. And after looking more into what happened, we figured out that some of the fake install we saw from Gooligan, thanks to server-side telemetry, were actually coming from devices which are not rooted, like Nexus 5. And we literally had someone giving us access to their phone physically, and also we did a forensic analysis of the phone, and it was not rooted, it was not compromised in any way. So what happened is they tried to increase the pool of device they had by having another way to infect the other devices with non-root app, but who will be able to do a fake request. So the reason why they were exfiltrating the token and all the information from the phone was, oh, we know this user, and we can create this realistic profile, so you can make this fake HTTP request from this app which were side-loaded from another store. So the phone we got was a Nexus. It was like a phone which was Android 5 and above, so it was not rooted but had side-loaded app, and those apps were making HTTP requests to the Play Store with the information. So the reason why we believe they were uploading all this information to the cloud was to try to diversify the pool of device, because they realized they cannot root anything above Android 4. So when you're on the phone and you need a token, what you do is you do the OAuth token exchange. And so basically what it does is it converts your long-term token, the one you have on your phone, to a short-term token which is used to do communication with the Play Store. So basically it's exchanging this. And while there was some confusion at the beginning, after investigating, we realized that the only thing they were doing is trying to get a token to do play abuse. And this abuse is hard-coded, we're pretty sure it's the case. And then with that, when they have this information, they actually use injections that was described by Oren to actually instrument and make the Play Store go inject the search query, as the user would do, go to the app, pretend to click on it, and then install the app with a package manager, which is standard on Android platform. And then optionally, sometimes they would like add a rating, like 5 out of 5, great app, or it might be in other languages, and they will do that quite a bit. So that's basically how it worked, and that's how they were using the OAuth token. So again, that's a new trend that we haven't observed yet. But And to give you an idea of how it works, that's basically what you get. You basically create a HTTP request, and the HTTP request contains a ton of information, including the token you need, and that's your form of authentication. So basically, the token is used as a way for us to know which user it is and to ensure that the user will count it toward their account and so forth. And it's all based on HTTPS request, right? Very standard. What's interesting about this abuse is while we didn't know about Gooligan specifically at the time when it started, we had a lot of defense in place, and all the fake install were already discounted, and then we came back and we cleaned up everything else, including we did suspend the app and the developer which were abusive. So they were the one benefiting from it. The app had no values for the user, and so we suspended this app as well. So there was, at the end of the escalation, no impact on the Play Store and no game ranking. We also observed in some of the sample ad injections. We still don't know which network it is, and I can explain why. This is what you see. So what happened is they abuse the root privileges to insert themselves into the accessibility, which allow you to overlay the UI with whatever you want. And what they were doing is we're popping up a real app. So the thing you see on the left side is a screenshot of a real phone where we actually tested the system and tried to see where it was going. And it's really hard to know who is behind it because there is a lot of attribution washing, which means they go through many measurement platforms, like to measure the click rate, and it goes through a ton of redirect chains. So we can't tell for sure who was behind it, but they were advertising legitimate apps. So it means that someone from those apps were buying in good faith install or promotion, and as a result, we're getting install from a botnet. So hopefully we were able to remove it, and so they're now getting install which are legitimate from real user, and so hopefully it's better also for those publishers. Thanks to the telemetry of Gooligan itself, we look at what they had, and we believe they were making sometimes 35 million clicks a day. That doesn't mean that 35 million install, it just means 35 million clicks. Some of them might actually come from other channels. As we mentioned, those were legitimate apps, so they may have, like, some of it might be the Gooligan stuff, and some might be advertisement on the website, or maybe other stuff, we're not sure. So it's basically the volume we saw. In terms of affected devices, it's very standard in terms of phone makers. The only thing to point out for people who are not familiar with the Indian market, Micromax is a very popular phone maker both in India and in Asia. And so it's not surprising. So it's a very normal distribution you would expect into emerging country. And as we said, the exploit kit only worked for Android 3 and 4. So we only saw Android versions which were KitKat and Jelly Bean. They make up of all everything. We did find extra devices, as we said, which were like 5 and above thanks to the telemetry, but they were not infected by Gooligan itself. In terms of distribution of where those devices come from, 90% of those come from India, and the top 8 countries make up for 50% of the infections. Because Europe and North America are more recent devices, they were not so much affected, so they're mainly untouched. So how do we clean up this? To do this, we had to do a two-pronged approach. So the first thing we had to do is work with third party, including Shadow Server, to be able to sinkhole the domains. So we have isolated the sample, and then we worked to make sure we had all the domains. And we worked to make sure those domains were sinkholed, so we prevent the exfiltration of the token. Do remember here that we cannot, for people who didn't have trusted boot, asking them to do factory reset will not have done anything because of the persistence mechanism. So we had to have a way to prevent the exfiltration of the token because any other remediation mechanism on the device would have failed. So we first started to do this takedown, and as we said, it was during Thanksgiving weeks, so a lot of people were out, but still we were able to work with with all the people needed which would be involved, including DNS, domain sellers and Shadow Server and other people to actually come up with a strategy. We sinkhole the domain. It was step 1. And the second step is we revoked all the tokens. We have a list of all the tokens affected, so we basically, for security measure, remove all of them. If you want to see the sinkhole efficiency, This validates why it was so important. Over the last year, we blocked over 50 million attempts of token exfiltrations. It doesn't mean there is 50 million people infected by Gooligan. It just means that those device members have been wake up, and then they will send it again, and people can't really remove it because factory reset. So they know about it, just decided that they will keep the phone anyway. And so about 50 million of those tokens have been stopped, and the distribution matched very closely the one we observed from the initial wave. We also had a huge sweat in March. When we look at the telemetry of the sinkhole, we see this huge jump. And you're like, oh my God, something is happening, Gooligan is back, and there's like 500,000 tokens exfiltrated per day. What happened is just like the sinkholing analytic was changed by shadow server, and so in reality it's still active, but this is just blocked, so it's effective at the moment. One thing we want to point out, and that's very important for people who reach out to us, or if you reach out to any other big company, try to understand that when we try to notify our user, it's very difficult. When you have to warn 1 million people that they've been infected, you have to make sure A, it's in their language, and B, you're able to reach them. So reaching out user is not that easy. We use the combination of a notification on phone, sending an email to the account, or sending an SMS. And we had to translate, of course, the notification in many, many languages, as well as the support page, because people will be concerned. And you don't want to create panic. You want to say to people, hey, we know about this, your account has been compromised, it is okay, here's what happened, here's what you can do, here's what's not going to work, and here's what you should do. And so the notification of the user is, for us, the hardest part of the takedown. It's not like the technical means when you work with people who knows about botnet and are very efficient, it's very, in a way, easy because you work among peers. Notifying user at scale has been a huge challenge, and making sure that people understand and can take proper decision was very important. So, takeaway about this investigation. If you haven't, the main takeaway for you guys who work on botnet is we believe OAuth-based botnet is an emerging threat, and you're going to see more of those. So if you don't know what OAuth is, you should look at it. We'll expect it to also target additional services for other reasons. A lot of people use OAuth now to delegate passwordless access to their app. So if you have an app who do that, you should be careful about it because it will happen. Second is, and we know that the first time we do it publicly on record, but we love to collaborate with everyone. So if you are aware of a botnet on Android or malware or transaction banking on Android and you want to talk to us, or on desktop or on anything, please come and work with us. We love to collaborate. Security is the responsibility of all of us, and there is no way one company can secure the internet, but all together we can. So please reach out anytime you want. And finally, we're really grateful of everyone who worked with Checkpoint and Google to help us to do the takedown very efficiently. There's a lot of people which are not there today, but really participated and helped, including Shadow Server. Very active people even during Thanksgiving weeks. So we hope you enjoy the talk, and we're going to take the question, but we're going to take them offline.
Sure. Hello.